Hi everyone. So we start today another devlog session. That will be devlog session number 14. So it's time to try to review a bit the latest changes that I have introduced here since the latest recording. When we finish the devlog 13, where we're working on this NVL context and NVL component implementation in Lua. And then well, I actually kind of changed a bit my focus because that's about the time when I started to think about WebAssembly support. So that's something that is on my to-do list now. Not very clearly, but that's still the idea. And so I realized that if you want to get WebAssembly support, you're going to probably have a hard time to introduce Lua GIT support in there. You can have Lua running in WebAssembly, but not really Lua GIT because this one is using, well, hardware specific code. I don't know exactly how it's working, but you have assembly code in there that will be tricky to compile for WebAssembly. So you basically lose Lua GIT, which means that you are back to square one when it comes to a proper scripting language in C++. That would be efficient and everything. And if you compare the performances that you can get from Lua and WebAssembly itself, I don't know where I've seen that. But that was not so good. I don't know. Oh yes, that was the one. So you have WebAssembly here, and in fact, even compared to Lua GIT, you might get a timeout in this case, as it's taking a long time, in fact, for WebAssembly, but it's working at least. And in other cases like this one, you can have... Oh, that's interesting. What are those compilers? I was not really aware of that. Compiler runtime. I have no idea what this is, but anyway, you can see that you can get 200 milliseconds, for instance, and with Lua GIT would be much slower. Here it's approximately, I know it's faster for Lua. Okay, hello world, but not so much. Here timeout again while this one is working. Very long time for Lua GIT, much shorter time here in WebAssembly. So you get the idea. Lua itself, Lua GIT, yeah, no match for WebAssembly anyway, which kind of makes sense because this is giving you performances that are supposed to be close to native. So yeah, I thought maybe I should not push it too far when it comes to the support that I'm providing inside Lua. And from that point, I decided to try to, try at least to provide the core functionality directly in C++. So starting with this get current working directory, get home directory. So I was, we'll come back to all of this later. This were added in my utility module, which is a bit dirty, I have to admit, but we'll do with it for now. So get home directory, it's still trying to mimic what I was doing in Python. So just checking the home first, but if we are on Windows and we don't have a home, then we'll go and check the Windows specific mechanism to retrieve the home location. So yeah, what about the current working directory? We're just using file system. Current path is what you need. Next, also, you can have boost in WebAssembly, but I thought, why use boost when you have the same support inside the standard library itself? So I started to remove a bit what I'm using from boost and replace that with what you have available in the standard library. So boost any and boost file system, for instance. We have seen, for instance, that here we use std file system now. And for boost any, this one was actually a pretty significant change, because at first I had what I call a data map, which is now an any map. And that's also part of the changes that were introduced here. Wait a second, I have a cat. Okay, the cat stopped yelling. So yeah, I replace this data map with an any map, and also replace boost, replace all with my own function to do that. So that's again going to be here. Replace all. It's a simple string manipulation function. What's next? Also, while working on this data map, I thought, okay, one of the first thing I would have to do then is, you know, in the Lua version, when I build the context, I was providing this kind of support to load the config from a simple Lua file. So that would be, in fact, a simple Lua table, which was really cool, but it doesn't work if you want to move that in the C++ layer directly. So I thought, okay, maybe it's time to provide support for YAML then. And I started providing integration of the YAML CPP library. And in this process, I have also built a mechanism to be able to parse a YAML file and generate, I was saying, an any map from that YAML content or YAML file here. So you see we have this parse YAML map now, which is this function we have here, which also means that we need to parse sequences. So that's a point where I needed to introduce support for any list, so which is similar to an any map, but it's rather a vector container in the end. At first, I was building that as a simple vector of any, but then I thought, okay, I need to make this a bit more sophisticated, so I provided a dedicated class for this. So renaming, updated. Yeah, another thing I would introduce in this process is, at first I was just using the std any directly, but this one doesn't really tell you what kind of data you have in the any. You can use the type ID, type info things, but I find this a bit inconvenient to use because it's not obvious what type this contains. So what I have now is a dedicated any structure, which is actually growing. So yeah, there it is. And in there we have any object, which is the actual data, but we're also storing the type as a string ID. And then we can check if this any is a given type of data, and we can get some specific type with a dedicated getter, which will be able to perform some conversion, which is not available out of the box with std_any. So yeah, that's it for the any modification here. What else? Yeah, at first I was just providing a vector for the analysis, as I said, but I had to, well, refactor this a little bit. So removing any from the base types as I was using it first. Also, I have been renaming some of these those containers. Everywhere where I was using a list name, like a float list, U32 list, and so on, I'm now using the same float but vector and U32 vector and so on. And for the ref float list, I will be using float ref vector. And after that, I could finally start adding my any list. And yeah, build the support for parsing YAML, cast any into given vector, any list, yeah. That's what you have in there, because when you have an any list, you could actually, because when you parse YAML first, you really only get to create an any list because you don't know what you're going to have in that inside. And yeah, I thought as an optimization, I could check if my any list contain. Sorry, I'm a bit sick. So I could check if my any list contain only bools, for instance, or only strings. And if this was the case, I could convert that directly into a ref vector of that object, that type, I mean. So it's a bit faster than to process, I guess, and at least you have a real vector of bool or a real vector of int value and so on. I actually then extended that to support also a list of any map or list, I mean, an any list containing other any list. So that would be converted into a ref vector also. I'm not quite sure if this really makes sense, but yeah, it sounds convenient to do. So support for those ref vectors here. And now I can finally, in fact, load my configuration from a YAML file. Sorry. Okay, so the configuration loading part. That's done just here when you can call load config. It's going to retrieve a YAML file, which is config.yaml. Just checking that this file exists, and then just read the configuration with all the utility functions we describe. Another thing I'm also working on more carefully now is unit testing for all this. So we have, for instance, a few additional tests for any list. Any map is basically what I had for data map. And this one is one of the things I'm working on. So a C++ implementation of the CoinGecko interface I had in Python. So I was starting to think about providing that in Lua. but now I am redirecting this to C++ implementation directly. Now, working on that, this led me to the request manager and a request classes. So these are what we have now in the network here. I think that's mentioned already. Not quite. Oh, yeah. Yeah. Replace the request manager with C++ function. Also, for the app component, yeah, I changed that a little bit also. Before, I had to register my components manually and init them manually. So probably, well, that's not visible anymore, but if we go in Vulkan app, for instance, well, here, where I'm just getting the instance now. Before, I had to first create that instance and call app register component, providing the instance that I had just created, and then call init on this object to ensure it was initialized. And only after that, the instance function here would work as expected. Now I modify that. So in the Nerve app, we can, well, it's not quite here. It's rather if you go and see Scene Manager, for instance. When I have to get an instance, I'm calling get or create component. So if the component is not available, it's going to create that. Except that this was probably the initial idea I had, and I, in fact, disabled this mechanism, and I was only using get component because there are cases where you cannot create a component when you're given a type like that. And this is simply because I have, for instance, the SDL, no, not that, SDL window manager, which is some kind of window manager with implementation of functions that are abstract in the window manager. But the window manager is the real well, the real component itself. Declare component instance. Which, if you think about it, maybe it's not so good idea to put that here. I could rather put that directly in the SDL window manager. Would make more sense. But anyway, there was a few abstract function in there. Like there's one, for instance. So you could not generate the corresponding component or compile this function. So what I did was instead to provide an intermediate interface. So the default component implementation structure here, which is going to tell you what is the real implementation you would like to use for a given component type that might be abstract. And from there, I could specify that for the window manager, not quite here, it's in the base. For the window manager, I would like to use the SDL manager. And with this, yeah, we can start using instance directly, and that would create the component as needed. Also, when we register a component now, so in this function, we also call the init function automatically. That was not done first, but I think it's safe to do it here. So that's it concerning this part. And then concerning the request manager itself. So we have been working on replacing the implementation that I was introducing in Lua. So I think, yeah, now we don't even have that anymore. So if we have a look at the crypto view app, you can still run a task with this price feed. Yeah, in fact, that's where I was at just before, I think. But now when you reach this, you're going to get the request manager directly from your C++ code. And for that, you're going to make a request, a GET request, which is going to provide you a response. And you can check if the response is awk and get the text from that response. And that's still working just that was before. No, that's not what I want to use. So I still get my message here. Okay. So yeah, everything is still in order. So for that, I have created the request manager, which is now also a component. And it's going to create a request object for each thread where you call this get default request. And from this request object, you can start performing some actual request. So that is the request object itself. And for instance, when you make a get request with a request object, you will get eventually a response. And this response can tell you what is the response code that you get, what is the body data that you got, and so on. So yeah, that's basically where I am at. And now the idea is to try to handle those 2 points. I need to implement some advanced mechanism to do a make request. Because this is what I'm supposed to use in the ConGecko interface. If you go in ConGecko here, so, oh yeah, by the way, we also have some kind of support for that. The initialization of the ConGecko now. You get the config from the app, which I should show maybe. So that's the default config we have for now. We just have ConGecko and a few stuff. So we can retrieve this. You're going to get the config, and from there you have any map, which is ConGecko. You can get this one, then you get your string, your float values, your integer values, and so on. So that seems to be working fine. It's still a bit rough and not very flexible, so maybe we could improve on that eventually. But for now, this will do. Still, if you go in the Python implementation, then we'll see that one of the first thing I should try to provide is send get request here, and this one is going to use make get request. Okay, and to do this make request, we have a few additional elements to take into consideration. So if we go in where we have this implemented, which is an object, the base object. So we can accept parameters, timeout, max retry, headers, retry delay, and so on. Why would you need that? Status codes. So first question is, where am I going to provide that? I probably need to have some kind of interface for that in the request manager itself. So I'm going to try to call that save get. Not quite sure if this will stay, but we'll see. Yet before I go further with that, I'm thinking also that this syntax may not be the best option for me. What I think I need is in the get request itself, in fact, we could provide that. And that could be a pointer, in fact. So that for the default parameter, you don't need to construct anything. And you could just set that to null ptr. Now, do we need this thing? I don't think that's necessary then. So you could just remove this one. Here again, you may also provide a list of parameters. But then the request here is messed up because you expect to provide this list of parameters. So you might just not have anything here. And that could be set to null ptr by default. Now you need to fix the actual implementation, of course. So we will have something like this. And yeah, in fact, you need to go. Oops. In this implementation, to get the buffer, and that's where you would try to modify your URL. How would you do that? Probably mean that you need a string to store the full URL anyway. Or no, you could just use your URL here. Okay. So you could do if balance. It's not a null pointer. You do something. Otherwise, you do something else. If it's not a null pointer, you do something to create a new URL. Oops. New URL, and otherwise, well, you use what is passed to you already. So you start with the base URL, and you would perform this concatenation, and then from there you call can I change that? It's a const char pointer, but the pointer itself is not const, so I think no, I mean it's not in range anymore. Let's not try not to be too clever, because you're going to break things. So that will be full URL, and you can start to const char. Okay. So with this, you're going to handle the available parameters or not. So this can be removed, but then I'm pretty sure I was testing that probably. Wait. What was I saying? Yeah, we probably have this tested somewhere in request, maybe. Yep. That's not working anymore. So we need a dedicated dedicated map. Oh, what am I going to call that? That's a bit of a pain. Could I not just use a string map? Or even better, provide the... I'm wondering if there's a way, a convenient way in C++ to provide parameters in an arbitrary order. I don't think there is anything worth trying here. But anyway, if we that's on a request, yes. So if we that's not even a map. Oh, because I'm maintaining the order of the entries. So let's say if we consider something like that. Oops. This would do the trick. Okay, then this becomes valid again. So we can try to build, except I was building that and it's not correct. In addition of building that, I should probably also regenerate the bindings. So we'll do that. Well, when you regenerate the bindings, actually, I'm removing the get function from the request manager and the request object, because we don't have support for this request param list. I was explicitly removing that. I'm not sure why exactly, but I was. So what should I do? I'm trying to restore this in the bindings and we'll see how this goes. Okay, when I restore the bindings for everything inside request, so basically removing here the dollar symbol to include everything in request, I get this additional file, and then we get the get function restored, but we also have a compilation error because of this. Sorry, we're using an incomplete request type, which sounds like something I could probably fix. Because compile context bind command should context and you are including this one in clang Lua core threads. Lua call threads. That's tricky because yeah, you have this class, but you also need the subclass. So what should you do? It's probably where we have the error. Okay. So you need to make a way to force include the request header file here. So let's go into, I have no idea what this is done. We are called threads. So let's just search for threads in there. Point H, common header writer. That's how I include the file. That's how I generate the file. So we need to required header get elements insert node his here class. That's interesting because I would have expected this to wait. Let me just fix that and we'll come back to it. Okay, so I'm adding some debug outputs and we see that for the request param list class, when we reach this point, we actually don't have any header file, which is pretty unfortunate. So let's dive into this and figure out what's happening. So digging further, I found that this is inner class function is returning probably false, and we're still using just the param list class itself, where I would expect to use the parent. So yeah, I don't know, how can I do that? It should really be in the parent class. Okay, I have to think about this. Okay, so I have updated a bit this is in your class function. Actually, I just replaced that with get parent class to be more direct. And so we keep the previous check. If the parent is actually your class, we just return that. But now we're also trying to figure out if the parent full name is matching a class name, because if you are considering that NV request in this case is a namespace, that doesn't mean that maybe there is no NV request class. It would be good if you could actually figure this out while processing the tree, the IST graph, I mean. But that doesn't seem to be working here, so we need to do that afterwards. Anyway, you get the parent full name, you check if you have a type or that, and if it's type, then you really expect the target to be an actual class. And in this case, you just check that and return that class. Now, with this change, you also need here to get the parent class. You check if it's nil first, but if not, you'll reach this point eventually. And next you're going to use that. So now if I go I mean, I already have the corresponding change here in core in Lua core threads, so you will see that we're now including network requests, which is good. And that's the internal class. And yeah, if I go in the log file, I'm sure that I will see by core processing this class of the target class is MD request, which is good. Let's remove a bit of those debug outputs. And we just generated the binding, so we're going to build and see if it's all working good. All right, so as you can see here, the application is still working and sending the request correctly with this param list argument, so we are all good. In fact, the argument is just set to nil in the file that we're using in Lua, but at least, yeah, that's accepted, so that's good. Next, what should we do? Okay, so going back to the implementation of the save get function, I think we can write it a bit like that maybe. So we start with the URL, then everything should be optional parameters, and I'm trying to classify them by order in which I think you may want to change them. And by the way, I just learned that in C++20 we have support for name and argument, which is great, but I'm unfortunately not compiling yet with C++20, so yeah, we'll live without it for the moment. Anyway, so I would specify the headers first, which I believe could be provided as a vector or strings. We'll see if this need to be changed. Then we have the parameter list. Then the timeout, which is set to 0 to indicate no timeout. Maybe I should make this a bit different, we'll see. Max number of retry delay in seconds, and the valid response codes. Again, that should be a list of integer values. So let's now move to the implementation side. Okay, so give me a moment to do this, and we'll comment on the result after it. So while implementing that, I realized that I don't really want to keep passing the parameters if they are available here to the get function every time. That's something you could just do once, so maybe it would be good to separate the parameter injection in the URL. So let's try to do that. Okay, so still working on this save get implementation, but in the process I've been introducing quite a few changes already. So let's get a quick review. So in the request class, I basically get rid of this parameter list support because really you don't want to have this specified for your get request every time. So you should rather build the URL once and just provide that. But you also may want to provide a timeout, so I'm providing support for this parameter here. Next, in the request implementation, we have the actual update of the code, and we use a timeout specifying a millisecond timeout. And if you set that to 0, it's actually disabling the timeout, so that's good for us. Also in the request response now, you can basically create a response that is empty at start and then set the result code here from the result of the perform call. Then also set the response code and the response body itself before returning it. So if we go into the response here, I have added support for that. And these are private methods because you don't want the user to set this, but you have request as a friend now. Also, using the result code, we can figure out if this response was timed out. And of course, it's not awk if it was timed out. And yeah, to figure out if it's timed out, you need to compare the result code with this. So you do that in the implementation file to avoid exposing anything from curl in the header. On the request manager side, we have this static function now to build an URL from a base URL and a list of parameters. So this is what we use now when we have parameters to provide in a URL. In fact, indirectly, this will be used in the save get here. And that's where I am, so I'm continuing. Okay, so final word concerning this make get request implementation. I've continued to work on the save gate function, but actually I just renamed that to get. And to avoid any conflict with the other simple version, I just call this one row get, because we're using the same parameters actually. So this one now is behaving, in fact, probably exactly the same way as the corresponding Python code. So we'll be checking for the result that we get. We may display error messages. Then we check for the response code. And yeah, we may also wait a little bit. And yeah, basically this is it. I think I've discussed all the changes introduced here. What about this one? Yeah, just added a couple of functions to support slipping and an helper template to check if a given value is in a vector. And I think we have already discussed everything else. Oh, also support for headers. I don't remember if this was already discussed. So I have a mechanism actually to support setting the headers only once on a request. Oh, which made me think I call this when I change the headers, but I should also call that when I destroy the request. Like this. For the request manager, we have those two functions, build URL with parameters. And this one we can check if we have a timeout, the result is awk, and get the result out of the string. And yeah, for the unit test here, we're still using get, which is in fact the advanced version now. And it's still working just fine. I made a change, but we can just run the test and you'll see it's working fine already. So I'm going to commit those changes, and in fact, I guess that will be all for this devlog session, because in fact, I'm already adding this new entry for a new day. So I'll mark all those points as part of the devlog 14, and then we'll continue our journey to provide support for everything we need for the CoinGecko component. So see you another time. Bye bye.